We introduced Seen2Scene, the first flow matching approach that can be trained directly on real-world incomplete scans to complete and generate 3D scenes. We treat scan completion as a conditional generative task, taking as input a real 3D scan, as seen on the left, which contains missing geometry caused by occlusions and limited sensor coverage. We learn to generate geometry in these missing regions to produce a complete high-fidelity 3D scene. Real-world scenes are captured as scans with range sensors, whose raw measurements can be fused into a sparse TSDF volume that encodes both surface geometry and visibility information based on the sensor, in particular unknown or unseen regions and known empty regions for visibility. The TSDF encoding of the partially observed scene is then fed into a sparse VAE, which compresses it down to compact sparse latent features. Crucially, the VAE reconstruction loss is applied only to observed voxels, so the latent captures only what the sensor actually measured. To train our visibility-guided flow matching, we separately consider the voxel latents representing surface, unknown, and empty space. We mask out unknown voxels and keep the empty and surface voxels. A sparse transformer is then trained on these latents using flow matching, restricting the model to learning priors over observed regions only. For scan completion, we then inject the input partial scan using a control net branch for conditioning. The model then fills in missing geometry while preserving the observed structure. We can also perform text-to-3D generation using our base generative model without an input partial scan as condition. For scan completion, we compare with SGNN and NKSR. Our approach recovers substantially more complete geometry, both in fine-grained furniture structure and complex spatial layouts. Here we show scan completion results on various ScanNet++ and ARKit scene scenes. Our method can recover both occluded furniture and fine surface details that were unobserved in the input scan. For 3D scene generation, we compare with Block Fusion, LT3SD, and WorldGrow. Our method produces richer geometric detail and more coherent room structure. Here we show text-to-3D scene generation. Although our model is trained in a patchwise manner, it scales beyond individual training patches through a tiling strategy. Overlapping chunks are generated independently and stitched through multi-diffusion into a single coherent environment. Thank you for watching.